Hello, welcome to Digital Electronics. Today we're going to be using a software called Multisim Live to simulate our circuits before breadboarding or even soldering permanent circuits. The first thing you have to do is go to multisim.com and either sign up if you haven't signed up already or log in if you already have an account. I already made an account, so I click login and I'm enter my email and my password. Hopefully I get it right the first time. I'm also going to click stay logged in so that I don't have to do this every single time. Once I click my username and password or my email and password, it takes me to my landing page. Here you see your profile information, how many circuits you have, if you're part of any groups, and any latest circuits that you have made. If you never made a circuit, that's okay. You'll have plenty of those after you do this tutorial and work on some circuits for your classwork. Now, what I want to do is show you how to make a new circuit. To do this, you click on Create Circuit. Once you click Create Circuit, you have a blank page in front of you that you can start working on. The very first thing I want to show you is how to save your work, because Multisim Live does not save your work constantly. You have to physically tell it to save your work. Notice that my circuit is untitled, and so let's first save it before making any changes. I click on the Wi-Fi icon on the top left corner and click Save, and I'm going to call my circuit my first circuit. You can call it whatever you want to. Now, there's an option for making it public or private. For all this work, we're going to keep it private so that no one can access our work. You can add a description and a tag if you would prefer. I'm going to leave it blank. I'm going to click OK and notice that my paper is now changed and it says my first circuit, and in the corner I got a little notification that my paper is saved. So now here, just to show you, if you want to work on your page and let's say you're too zoomed in or too zoomed out, you can use the scroll wheel on your mouse to zoom in or out. You can also use the plus and minus arrows on your page on the top right corner. Let's start building a circuit. On the left hand side, you have all the components that you will be using in class. I want to make a note though that make sure your account is upgraded to premium with your teacher gave you a serial number. If you don't have a premium account, you will not see all the components that are shown here. But everybody should have a premium account for now. So now here, what we're going to do is we're going to click on sources and notice how a little menu comes out and you have more options. This is where you'll find a battery. It's called DC voltage. Click on it once and there's going to be a battery following your mouse on the page. Click once more and the battery is placed on the page. Afterwards, if you want to move it, it's very intuitive. You just kind of move it around by clicking and dragging it. You can close it by clicking the X. It gives you little hints right there. You can delete it. Here you can duplicate if you want one more, or delete that one. And you can rotate. You can also mirror image. This one is vertical, so it doesn't really mirror anything. And what I want to show you also is that by default, any voltage supply, or this battery, for example, is called V1 and it's set to 12 volts. To change that, you select it and you click on the properties or the little gear icon on the top right hand corner. Here on the gear icon, you see you can change the name. I'm going to call it battery and I'm going to change it to 10 volts. Even though there's no battery that's ever 10 volts exactly, unless you have a custom made one. So here's my battery. Now notice if I click on the page, my settings change to the page simulation settings and the size of my page. I can even get rid of the grid or put it back. If I click on the battery, the gear or the little settings property over here on the right changes to the properties of the battery. Now, here, I'm going to place a couple of resistors, actually 3 resistors. So you can see the icon for a resistor is right there for passive components. And there's lots of other components, but I'm just going to put a resistor. Notice that I can also press the R key to place the resistor. So now that I'm here, I can press R on my keyboard and place as many resistors as I want. I'm going to connect them in series. So what I want to do is take this one and rotate it so that it's now vertical the way I would typically connect a series circuit. I'm going to move the page by clicking my paper with my mouse and moving it to where I want it. I want it nice and centered, and then I'm going to use my scroll wheel to zoom in. To connect it is super simple. All you do is move your mouse to the connection endpoints of each component, and you get a little spool of wire pointer rather than your hand. When you get that little spool of wire, you click once, and you click once more to finish the connection. Notice that the wires also have names. In this case, is wire network 1. This is wire network 2. You can also delete the wire. But if you want to change or delete, if you don't want to see the numbers of the networks, you can click on the, again, whatever you click on, it's going to show you the properties. So I'm actually going to get rid of the net labels. So then it's not going to show the net labels right there. So it's up to you if you prefer to see them or not. Yeah, there you have it. So now I'm going to finish connecting the rest of the circuit right here. I want to tell you that you don't always have to make the wires automatically route the way they are. If let's say you wanted to make a very specific shape of wire, all you do to anchor it on the page, you click once. Notice I'm clicking every single time wherever I want the wire to go, and the wire will follow the path that you anchor it to on the page. You can also move the wire by just clicking it down or left or right, however you want to organize your wires. Again, for this first circuit, I don't want to see the network names, so I'm just going to delete them. So there's my first circuit. Now, I don't want them to be all 100 kilo ohm resistors. Let's change this a little just to get numbers a little different. The second one, I'm going to move it to 500 ohms. So I'm going to leave the first one, and the third one, I'm going to make it 2.5K. So I just type 2.5K, and that's my resistor values. Now, Multisim and maybe many other softwares needs to know where to start. So what we have to tell it is where is 0 volts in order for the simulation to occur properly. So what we have to do is tell it that 0 volts is right here on the negative side of the battery, and 10 volts is on the top by default because it's a 10-volt battery. So to tell it that 0 volts is at the bottom here, what we need to do is place this device called ground. It's not really a device, it's a connection to earth. So here we put the ground and we connect it to the negative side of the battery right there. And that tells the software and the code in the background that this is 0, and from there you work through the circuit. That's always necessary in simulation software, even though in real life you may not need to ground a small circuit like this. That's more for safety purposes in real life. But for software, we need it there. So we put it there. Okay. Now, if I start my simulation at this point by clicking the little play button on the top left, I won't see anything because I haven't connected any instruments to see what's happening. Even down there, it only connect something to graph the data or something. I'm going to stop the simulation because I cannot edit with the simulation running. And I'm going to measure some values. Now, Multisim Live does not have multimeters the same way we have them for our handheld measurement device. But they have these little probes right here on the top left, the analysis and annotation. There's voltage and current, and other data and digital probes. I am going to use the combination of voltage and current at the same time, so I can measure both at the same time and not have to worry about putting multiple probes. So by using a probe, notice that you get a little arrow that's kind of hollow, and when you put it on top of a wire, it becomes solid. That's what you want. So what I want to do is I want to measure the voltage and current going through this wire at this point. And if I press play, it's going to update and give me my measurements. Once I give the measurements, you can stop it, and then it remains the values showing. So here, notice that there's 10 volts because I haven't gone over any obstacles, but it tells me my current. So how does that help me? Because I want to know the voltage used by this device. Well, it's a simple little math calculation. It's not that hard whatsoever. You just have to subtract. So notice I placed the second voltage and current measurement probe. And if I press play, it's going to update. I'm going to stop my simulation. And so I start with 10 volts at the top of the battery, positive side. And at this point, I have still 10 volts. But after I overcome this first obstacle, this first resistance, now I'm only left with 7.5 volts. As you can see, 10 minus 7.5 is 2.5 volts. So I know that this device uses 2.5 volts. Now, at this time, I can use the text tool right here. Notice, I don't know if you saw it, but right here, I can use a text annotation. And I can even add a new text label here. And I'm going to type 2.5 volts, just so that I know that this device uses 2.5 volts. You don't need to put it there, but since I'm showing you how to do it, I'm putting it there. Now, what if I want to know how much voltage this device uses? Well, I know before going through the obstacle, I have 7.5 volts left. I'm going to kind of poke the wire right here. Notice my arrow points downward in the direction of current flow. I'm going to press play, and it should tell me, I'm going to stop the simulation after it reads the measurement, it should tell me how much I have left now. So I started with 7.5, and now this third probe, now I'm left with 6.25. Just make sure 7.5 minus 6.25, that's 1.25, right? You can always use a calculator if you want to verify it. So you would type in 7.5, that's how much I start with, minus 6.25. Enter. And like I said, it's 1.25 volts. So that's how much this voltage is, this resistor uses. Again, I'm going to use my little text tool. Notice I moved the circuit a little to the left so that I can put it right here. And I'm going to add text, and I'm going to say this one uses 1.25 volts. And I'm going to put it somewhere nearby. Now, I want to know how much this one is using. I have 6.25 left after the second obstacle, so I need to measure how much is left afterwards. So one last one right here, but there's a small problem that I want you to note. Here, the current is following, the arrows follow the current flow. Notice it's going in this direction. I'm left with 7.5 in this direction. I'm left with 6.5 in this direction. And now this current arrow is backwards. Notice what happens if I run my simulation. As you can see, it gives me a negative reading. That's not correct. What I need to do is reverse this probe so that I get a correct or positive reading. I click on the probe, and on the properties, as for any other device or component, I tell it to flip the current measurement. See, if I keep clicking on it, it just flips it back and forth. I want it to point in the direction of current flow, so that is correct. I press start simulation again, and it's going to refresh my values, and now I know that it reads 0 volts, which is correct, because by the time remember Kirchhoff's law say that you start with all the voltage, by the time you go through all of them, you're left with 0. They should add up to 10. So again, this math is easy. 6.25 minus 0 is 6.25. So I know that the voltage used by this last device is 6.25 volts. So there it is. I have 2.5 plus 1.25 plus 6.25 equals 10. And you expect that the largest obstacle, in this case the 2.5 kilo ohms, uses the most energy. And the smallest obstacle, which is 500, uses the least amount of energy or voltage. So that's how you figure out the voltage used by this device. Now notice that the current is told to you directly. You don't have to do any math. It tells you that there's 2.5 milliamps everywhere because there's only one current in series. It's slightly different for parallel. Let me quickly build the circuit in parallel to the right. I'm just going to cheat a little bit by grabbing that battery, click on duplicate, and grab another resistor. And now notice that this battery got a different name. It added a 1 because you cannot have two devices that are named the same thing. And I had 3 resistors. This one got called resistor 4. If I duplicate, this one is 5, and as many as you need. I'm going to put 3 for now. So let me connect these devices right here. I am going to just click away from here, connect it to the top, and then connect the wires from the connection to the wire. You cannot go really from a wire up. You need to go from where there's a little connector to the wire. Don't forget your ground connection on the 0 point of the battery, or the negative side. Now, let's change these resistor values to something not so confusing. Let's make this first device 40. I'm going to make it 40K so our numbers are not, we have a lot of decimals. On the next one, I'm going to make it 30K. And the last one, I'm going to make it 120K. And the battery, I don't want it 10. I want it to be 6 volts. They do sell 6-volt batteries. Anyways, so to measure a parallel circuit, it's going to be slightly different than measuring a series circuit. Now notice also another thing here. It says out of date because I've been modifying my circuit. But the moment I press play again, it's going to be refreshed. But let's measure these first. So what I want to measure on a parallel circuit, let me close that so I can zoom in a little more. In a parallel circuit, I know it behaves different than a series circuit. In parallel circuits, I only have one voltage. In a series circuit, I only have one current. So what do I need to measure? Well, I always like voltage and current at the same time, so I get all the values. So what I want is I want to know how much current is coming out of my circuit right there. Then I want to know how much voltage and current is going through this first device. So notice I'm not connecting them on the wires up here. I'm connecting them right next to the resistor and the last branch. And then I want to know how much comes back out to the beginning. Oh, but this one's going to be backwards, remember, because it's facing the other way, so I need to flip it. All right. So now let's see what happens. I'm going to press start the simulation, and it refreshes all the measurements. And then I'm going to stop it, and notice all the measurements are refreshed. Very well. So in parallel, I start with 6 volts, and you can see here I have 6 volts with 400 microamps. Now, this first branch still sees 6 volts. The second branch also sees 6 volts, and the third branch also sees 6 volts because all this wire is just one network connection. Afterwards, I see 0 volts, as you can see. What is different from each of these branches is the current. I start with 400, 150 go through this branch. Actually, let me put another one here just to show you what's going on, and one more here, and make sure it's facing in the direction of current flow. Okay. So what you will see is that the current keeps splitting and then joining back together. So here we have 400, and then 150 out of that 400 goes in this direction. And the remaining 250 microamps goes to these other two branches, and then it splits into the 200 microamps and 50 microamps because they add up to 250. Then after the current goes through each one, it joins back up to be 250 as it started. Then the 250 joins with the 150 to become the 400 total to go back to the battery. So as you can see, on this one, for parallel, there's no math involved. It's 6 volts for each device, and it is 150 for the first branch, 200 micro for the second, and 50 micro for the third. And they add up to 400, which is the total. You can measure that on top or on the bottom. Now, to recap, let me close the properties windows. To recap, in series, you have to do a little bit of math. It's simple math. Just subtract the before and after voltage to get the voltage used by each device. But the current's the same everywhere. In parallel, you need to measure the current of each branch, and it's given to you directly, the same as the voltage. There is no math involved. This red and green probe are not really necessary. I just put it there for demonstration purposes to show you that the current keeps splitting. But I could probably delete it. I don't need those at all. This is all I need. All right, I hope that was helpful. Just remember, save your circuits every time so that you don't lose your work. If you don't save it and you exit this online or this web-based application, you're not going to have your work saved. At any time, if you want to go back to your circuits, just click on the waffle icon, click on Go to My Circuits, and you will be able to see all the circuits that you've worked with. And to work on any again, just click on it and get to work. I hope that was helpful. We'll see you next time. Ta-ra for now.